All right, so we are finishing up the notes from day 6. Put your compass on the vertex of the angle you're bisecting and make an arc through both rays. Make an arc through both rays for me. Once you have an arc through both your rays, make a point, make 2 points of intersection where they went through your rays. All right, just put 2 points on there because that's going to come into play next. So when you have your arc that intersects in 2 spots, mark those 2 spots. Everyone's got it so far. Mark the 2 spots. Okay, we come back over. Now, this next step, if you had the same opening as you did your first arc, that's fine. But these next 2 arcs we make have to be the same opening of your compass. All right, so if you right now, if you want to keep it, you want to narrow it, you want to widen it, doesn't matter on this next step. But the final 2 steps here have to be the same opening. So put your compass point on one of those points of intersection. And above that one, if it happens to intersect, fine, I don't care though. Above that one, you're going to make another arc, not too big. If it happens to intersect your first one, that's fine, but that's not the purpose. And then using that same opening, remember these 2 have to be the same opening of your compass. Using that same opening, go down to the other point of intersection and make sure this 3rd arc intersects the previous one. So it kind of looks like you got some fireworks going on. All right, those last 2 arcs you make have to intersect each other. And they have to come from each point of intersection. So all it is should be 3 arc marks on your diagram. The last 2 intersect each other. Grab your when you have gotten to that point, grab your straight edge, line it up with the vertex, and draw in. What are we supposed to construct here? Ray AX. So number 1, make sure it's a ray, and number 2, you put an X on there. All right, if I'm going to name it Ray AX. So line up your straight edge with vertex A and that point of intersection. Somewhere on that ray should be an X because that's what it asked me to name it. All right, let's do this again without my help. Now you got plenty of white space there. Draw, sketch your own angle for me, please. I don't care if it's a acute angle, an obtuse, and a right angle, it doesn't matter. Draw your own angle, and then I'll walk around and see you bisect it for me, please. Construct a ray that's going to bisect your angle. 3 arc marks, that's all we need here, 3 arc marks. So go ahead, bisect your angle, please. First step, make an arc through your angle. Put both points of intersection. Yep, go ahead. Mm-hmm. Okay, so you got, now you go to your point of, you got to go to your point of intersection. That way. Yep, make an arc above it.
Yeah, just do it at each point.
Yep, and you want them to intersect each other. I don't care if it intersects the first one you made, but these 2 you're making right now have to intersect each other. After you make that first arc and mark the points of intersection, then you put your compass on those 2 points and make 2 arcs that intersect each other. I'll grab a new one then. We'll grab a new one so we're not wasting time. Any issues? I'll put it on each point. Make 2 arcs above that intersect. Okay, any problems here? I didn't make a mistake, but I did forget something. I should have told you to do what to your diagram after we were done. How do we know that's an angle? I can tell by the constructions that that's an angle bisector. I've been doing this a while, but how are you going to know, or somebody that walks in, how are they going to know that that's an angle bisector? What should we put on there? Arc marks showing me which angles are now congruent, right? Show me which angles are now congruent. And make sure we talked on Monday, offset them. Offset those arc marks so it doesn't look like one full one. All right? Any questions bisecting an angle? We're building. Tomorrow we do all constructions. There's more constructions we got to do. And some will be on the unit test. Any questions there? Okay, day 7 now. Day 7. You can just put them off. Put your compass straight edge off to the side. That's all we needed it for today. Let's build on our knowledge of angles. Build on our knowledge of angles. Some of which you probably heard about, some of which you have not. First, I want to talk about when two angles are adjacent. When anybody hear the word adjacent, what other word do you think of? No, anything? What? Adding? Okay. Next, I always think next to. All right, when somebody says the word adjacent, like I live adjacent to this person, I'm thinking next to. And that's what adjacent angles are. They're next to each other. But they have to follow some rules. They got to follow some rules. Number 1, if two angles are going to be adjacent, they got to share the same vertex. Remember what a vertex was for yesterday, right? They have to share the same vertex. Number 2, they have to share a common ray. They have to share a common ray. So they have to have the same vertex. They have to share a common ray. And this is the part I'm going to help you with. They cannot have any interior points in common. And I'll show you what that means while we're doing it. So you guys worry about same vertex, same share array. You guys worry about that part, and I'll show you about what it means to have no common points, interior points. So look at diagram A. I got angle A and angle X and angle Y. I want to know if they're adjacent or not. So let's go through it. Do they share a vertex? You're darn right they do. Both of them have the same vertex. Do they share the same ray? Or do they share a ray? Yeah, right here. They both share that one. Now, here's what I mean by they don't have any points in common in the interior. Everyone put a point inside angle X right now. Anywhere. Go ahead. Put any random point inside angle X. Is your point also in angle Y? No. Is there any point you could possibly make that's going to be in both at the same time? No. So that's what that means. They do not share any interior points. So these two angles right here are adjacent angles. They share the same vertex, they share the same ray, and they have no interior points in common. All right, let's look at B. Do they share the same vertex? Those two angles, do they share the same vertex? No. So we're done talking. I don't even care about the rest. If they don't have one of them, they're not adjacent. They do not have the same. Here's the vertex for Y. Here's the vertex for X. They don't have the same one, so they're not adjacent. Even though, they look next to it. No, they don't share the same vertex, so these are not adjacent. All right, just so we understand what I'm showing you in letter C, angle Y is this angle right here, all right, kids? Angle Y is that angle, and angle X is the full one here. That's what we're talking about with angle X. Ready to go? Let's go through everything now. Do they share a vertex? Woo! Yes. Do they share a ray? Right here. That's angle Y and part of angle X, right? We're good. 2 for 2. 2 for 2. All right. Do they share any interior points? Hey, put a point inside angle Y right now. Put a point inside angle Y. Guess where it also is? It's also in angle X, isn't it? And that can't happen. They cannot share any interior points. So that's what makes this one not adjacent. Any issues seeing if it's adjacent or not? So just don't think next to. It's got to follow a couple rules. All right, I'm moving here. Complementary. I think you guys have heard of that term before. Nope, maybe. Complementary. 2. Hey, not 3. 2 angles only that add to 90. 2. Well, what happens if I have 3 angles that add to 90? You know what we call that? 3 angles that add to 90. All right? It's complementary is specifically reserved for 2 angles only. So, quick diagram. Back in your middle school days, here's probably what your teacher gave you. Oh, here is a 40-degree angle, and here is a 50-degree angle. Those 2 kids are complementary. That's probably what they did to you in middle school. Welcome to big boy, big girl math. I'm not going to pull that. That's way too easy for us. Instead, what I'm going to do is this. You're going to see this diagram, and here's what I want you to get down. Ooh, we talked about that symbol before. Angles 1 and 2 are complementary. I don't even know the degree measure, and I don't care, because I notice when I put them together, what's that box stand for? They add up to 90. I don't know if one's 30 and 60, 10 and 80. I don't care. I know they add up to 90 because I see the box. And also, give me another vocabulary term for those 2 angles. They are complementary, and they also are, yes, adjacent. There we go. Now we're going to start talking some geometry. Add to 90, and they form a right angle, and they're adjacent. Questions? Supplementary. Make sure you don't confuse these 2. Ho ho! Supplementary. 2 again, got to be 2. Angles that add to a $1.80. All right, have to add to 180. So you know what happened back in middle school, right? And that angle's 150. That angle's 30. Okay, kids, they're supplementary. Not here. Not here anymore. Ready? This is what I'm going to give you. Ready? Have this one down. Whoop. Where's this one here? Nope, wrong direction. Whoop. There we go. 1 and angle 2. I don't even know what their angle measure is. I don't care. How do I know they're supplementary? If I put them together, what's it form? A line, a straight angle. And Monday, what we talk about? Every straight angle measures $1.80. That's what we're going to see now. Okay, that's what we're going to see. And also, not only are they supplementary, they're also what? Adjacent. Those 2 are adjacent as well. Woo! All right, questions, comments between complementary and supplementary. Lines add up to 180. All right, let's move. I got some new terms. Keep going with the new terms. Linear pairs. Linear, what word I got in there? Line, perfect. So that's 2 angles that are adjacent. They have to be adjacent that form a line. All right, 2 adjacent angles that form a line. So let's go through each diagram here, A, B, and C, and you tell me if you think angles 1 and 2 are linear pairs, adjacent angles that form a line. What do we think with A? Angles 1 and 2. Well, they're adjacent. I agree with that. But what's the problem? Do they form a line? If I take angles 1 and 2 and add them up, do they form a straight line? No, they do not. I need the other angle there, which it's not labeled. So I'm just talking about 1 and 2 only. Everybody see they're adjacent, but they don't form a line. So this is not a linear pair. What about B? What do you think? What do you think for B? Are those linear pairs? What do we think? Adjacent and form a line. Yeah? Maybe? Yes? No? Yeah. They're adjacent to each other, and they form a straight line when I put them together. So this is a linear pair. And how about C? What do we think about C? Linear pair or no? Are they adjacent? Remember what it meant to be adjacent. Do they even share a vertex, guys? Do they even share a vertex? So can we stop talking now? Right? They're not even adjacent. They don't share a vertex. Well, who cares now? Not a linear pair. Here you go. Congratulations. You've reached the point in this course where I'm going to give you your first theorem. First thing, what is a theorem? Just figured it's a geometry fact. Okay, it's a geometry fact. We just call it a fancy name called a theorem. All right, called a theorem. It's a fact. Geometry fact. And here it is. I'm going to start it. You're going to finish it. Linear pairs are blank. And I am looking for a specific vocabulary term. And it's not adjacent. Good try, though. It's good, though. Linear pairs. Look at up here. Is there anything else you could tell me about that linear pair other than it's adjacent? Using a vocabulary term we have already discussed today. Anytime you have a linear pair in front of you, hey, you want to try to finish it? They're supplementary. Bingo. All right? Anytime you have a linear pair, they automatically add up to 180. So any linear pairs are supplementary. Okay? Linear pairs are supplementary. Yes, they are adjacent, I get it, but I'm going to be looking for their supplementary now. Questions? Next pair of angles, you had linear pairs, now we have vertical angles. Vertical. Just let me take you down the road here and then we can go over these examples. Two lines intersect, how many angles did I form? Everyone agrees I have 4 angles right here. 1, 2, 3, and 4. I'm going to make this easy for you. The ones that are opposite each other are called vertical angles. So 1 and 3 are vertical. 2 and 4 are vertical. Let's see if I got you right now. Let's see if I got you. I would never call 1 and 2 vertical. Never. We already have a name for those two. What's 1 and 2 called? What's 1 and 2 called? Linear pairs. All right? I wouldn't do 1 and 4 are vertical. What do we call 1 and 4? Linear pairs, right? If they're not linear pairs, they're probably vertical. They're opposite each other. So 1 and 3 are vertical. 2 and 4 are vertical. Go to my diagram now. Letter A. Are angles 1 and 2. Now I'm going to start calling on numbers. Are 1 and 2 vertical angles? Yes or no? Are 1 and 2 vertical angles? What do we think? Woo, let's go. Jackson, are they vertical? No, but they are what? Change it. Linear pairs. Darn right. They're supplementary. Nice. So these are not vertical. They're linear pairs. All right, next up, part B. Ooh, they have to be, listen to me before I call on somebody. Vertical angles are formed by 2 intersecting lines. Not crooked lines. 2 intersecting lines. So what do we think on that next diagram there? Oh, Quinn, what do you think? Are they vertical? No, they're not even lines. They're opposite. No, they're not lines. It's got to be formed by intersecting lines, not vertical. Nice. All right, and then how about C? Do those look vertical? Whoo, Madeline? No. What's that? No, they're not opposite. Formed by 2 intersecting lines. We're looking at part C, right?
Oh, I'm looking at it.
No, we already said they're not vertical. We're done. Going to C. Are they vertical? Everyone agrees C's vertical. 2 opposite angles. Difference. Are we okay? Linear pairs versus vertical angles now. All right, next fact. This is about vertical angles, and you guys don't know this one yet. You're going to find out quickly. Vertical angles. By the way, can we just quickly discuss having self-respect in this class? Having self-respect and spelling things correctly. The word vertical. C-A-L at the end, not C-L-E like the word barnacle. Okay, all right? C-A-L at the end. Self-respect, everybody. Would I ever take off if you spell it wrong? No, but I'll make a comment about maybe reevaluating your life. Okay, C-A-L at the end. C-A-L. All right, so what do I know about vertical angles? They are, and I'm going to leave a blank there because you are going to figure that out with me. All I need from somebody right now, all I need is give me an angle less than 180, please. Any angle, give me less than 180. Please make it like a 0 at the end or a 5 at the end to make it the calculation easy on me. Okay, just give me any angle measurement here. Let's go, Alex. What do you have? All right, something else than 90 because that's not going to do it either. 50. All right, everyone take a look. I'm going to call angle 150. You don't know it, and you're probably not confident enough, but you should be able to find the other 3 angles now. Angle 4 and angle 1, what do you know about them? Okay, more than adjacent. They're linear pairs, makes them supplementary. So what's 4? I don't think, do we need to count? 1, 30. What do you know about angle 3 and 4? Linear pairs, they're supplementary. So what's angle 3? 50. Maybe some of you are starting to see it now. What do you know about angle 2 and 3? Supplementary again, so angle 2. Anybody want to fill in that blank there? Vertical angles are? Vertical angles are? We have a much better word in this class this year for instead of equal. They are the same measure, makes them congruent. Vertical angles are congruent. There it is. Vertical angles are congruent. Linear pairs are supplementary, but vertical angles are congruent. Okay, good. All right, I got probably one more here, and then you're doing a lot of the work after that, practicing in your group. Anybody heard the word perpendicular before? 2 lines that form a right angle. Those are parallel back there, Keating. All right, thank you. Yes, those are parallel. Perpendicular, 2 lines that form a right angle. So give me 2 lines, please, that look like they form a 90-degree angle. Let's call this AB, and let's call this CD. You have no idea if these are perpendicular or not until I add a symbol to it. What symbol should I be putting on here? 2 lines that intersect to form right angles. So what do you think you should have on your diagram? You can't go because it looks like it. Get out of here. What do I need to add to my diagram that says, oh, they're perpendicular. I see that they form a right angle.
The square in
the box, right? Yep. So that's what I need there. Now you can tell me those lines are perpendicular. How do I write it? Everyone write line AB. Go ahead, off to the side. You guys know how to do that by now. Line AB. Make a space between it and put line CD. And we need to talk a new symbol now. So AB, CD. Anybody know the symbol for perpendicular? So far, I've shown you congruent. I've shown you parallel. What about perpendicular? Anybody know that one off the top of their head? It's okay if you don't. Upside down, capital T. There it is. That's the symbol for perpendicular. There it is. A lot of symbols here, huh? Questions? All right, I think it's time to, time to work on your own here. So go ahead, 1 through 6. You can talk it over with people in your group. I'll give you about 3 minutes to find those missing angles. Notice my everyone look at your diagram first. Everyone see I put the right angle there. So now you know angle EBC is 90 degrees. So hopefully that helps you. So go ahead, numbers 1 through 6. Numbers 1 through 6. And yes, you can talk it over with people in your group. Or not. Okay, everyone's looking good, finishing up. If you hear an answer and it's correct and you're not too sure why it's correct, let me know. Okay, let me know. Here we go. Number 1 here, EBF. What do we get for angle EBF? 18. Where are we going for that one? Keating? 51 degrees. Looks good to me. Again, let me know if you want to see why. How about number 2, angle EBA? What are we looking at for EBA? Izzy's not here. Going to 3 now. Mia, what do you have? Where's my 90, huh? That was an easy one. Got off easy there, huh? 90 degrees. How about DBE? Angle DBE. Oh, Juliana, what do you have? 17. Good so far. Any issues, questions with any of these answers? How about DBC, number 4? DBC, 2s. Owes me big time tomorrow. Owes me big time. So we'll go to 6. Jackson, what do you have for that one? Number 4, DBC. Bucks, what do you have? Buck 7. Good. How about ABF? ABF, 12. Lennon, what do you got, boss? 151. I have 10 degrees less than that. ABF. So yeah, we had DB. We found. You found DBE to be 17, right? And this one to be 51, right?
Yeah.
So ABF would be all 3 of those added up. Okay. 141. 141. Okay. Just make sure you're good there with adding them up because I just had 10 degrees less. And then finally, how about DBF? DBF. Now we had to add up 2 more angles. DBF 11. Jayla, 68 degrees. Okay. Any issues? Not bad. All right. Before we leave today, I want to go over one more. So can you go to number 8 for me, please? I'm going to skip over 7 and go to 8. All right. Read through 8. I'm not expecting you to know how to do it at all. We know first, I got 2 angles that are supplementary. What's that tell me from today's class? That they add to 180, right? So I have 2 angles. This angle plus this angle equal 180 degrees. At least I know that because they told me they're supplementary. Now here comes this new fact that those 2 angles are in a ratio of 7 to 2. Let me explain to you what that means and maybe you can help me out with the equation. If they're in a ratio of 7 to 2, what the problem is saying is one angle could be 7 degrees, the other angle could be 2 degrees. But does that make sense in this problem? No, because we know they have to add to 180. So any multiple of 7 and 2 would work as well. So for instance, it could have been 14 and 4. See how I just multiplied them by 2? But would that work? No. All right, let me keep going. Let me multiply by 3. It could have been 21 and 6. Is that going to work? All right, I'm done with it. I'm already getting fired up and frustrated. I'm done trying to guess and check here. All right, figuring out what do I have to multiply 7 and 2 by so I can get 2 darn numbers to add to 180. So how about we do this? 7 and 2, what do I need to multiply them by to add them and get them to equal to 180? What do you think I'm going to put next to each of them to figure out what is that number I need to multiply by? I'm just going to put an X with them because 1 didn't work, 2 didn't work, 3 didn't work. So darn it, what number do I need to multiply by each of them so I can add them and set them equal to 180? So anytime we get a problem with numbers in a ratio, automatic, I put the X's with them and put them in the equation. All right, anytime I have 2 numbers in a ratio. All right, let's solve it before we head out of here. 9x equals 180. Everyone's dividing by 9 and getting x equals. All right, now let's stop though. Does that mean 20 is one of my angles? No, 20 is the number we need to multiply 2 and 7 by to get those angles. That was the number I was trying to find, is the 20. It doesn't mean one angle's 20 degrees. Plug it back in right now. 20 times 7, one of the angles is 140. And then I do 20 times 2. Other angle, 40. And now look, quick check. What do you notice about those 2 angles? They add up to 180. That's what I needed. Okay, they add up to 180. So anytime you see those numbers in a ratio, put X's with them, please, tonight. All right, good job.